At 22:19 hours on February 3, 1945, Flight Lieutenant James Flint was about to make a decision that would kill 347 people without dropping a single bomb on a human target. His airspeed indicator dropped through 180 miles per hour, 18,000 feet over Berlin, 6 minutes to drop altitude. Behind him, 159 other RAF heavy bombers carried 14,000 pounds of high explosive each. But their target wasn't a factory, wasn't a bridge, wasn't even a building that most people would recognize as strategic. They were about to bomb water itself. And what the Germans didn't know, what they couldn't know, was that this attack would do something no previous bombing raid had achieved. But I'm getting ahead of myself, because to understand what happened in the next 42 minutes, you need to understand the mathematics of infrastructure assassination. The instrument panel glowed amber in the darkness. Outside the Perspex nose, searchlights swept geometric patterns across cloud layers 8,000 feet below. Flint's H-2S radar painted Berlin as a bright blob on the cathode screen, the river spree cutting through it like a dark vein. What he couldn't see was that the city's water infrastructure, built over 60 years, designed to supply 4.3 million people, was about to be compressed into rubble in less time than a university lecture. And here's what makes this story different from every other bombing raid you've heard about. This wasn't strategic bombing as the world understood it. This was something new, something the Germans had never seen before, something that would change how wars are fought for the next 80 years. The operation had a designation before it had name, Air Staff Order 1456/45, issued January 27th. 8 words buried in paragraph 3 would rewrite the doctrine of modern warfare. Precision attacks on utilities essential to industrial war production. Translation: find the pipes that keep a city alive and sever them. But here's the part that should terrify you about how precisely they'd learned to do this. The target folder for Berlin listed 11 primary water pumping stations, 4 main reservoirs, and 127 miles of primary distribution mains. The RAF planners circled 6 installations in red ink. Just 6. Destroy these, and Berlin's water pressure would collapse like a punctured lung. Want to know the mathematics that proved it would work? Because this is where it gets clinical. Berlin consumed 340 million gallons of water daily. Industrial plants required 180 million of that. Steel foundries, chemical works, munitions factories, all dependent on pressurized flow. The city's fire brigades had already used 900 million gallons fighting incendiary raids over 3 years. Emergency reserves drained. But here's the calculation that closed the operational case, the one number that made this mission inevitable. Without water pressure, Berlin's 10,000 fire hydrants would become decorative ironwork. The next incendiary raid wouldn't just burn the city, it would sterilize it. And one man was about to walk into Bomber Command headquarters with a plan so elegant, so mathematically precise, that it would be approved in a single meeting. Group Captain Sidney Bufton, January 29th, 1945. He walked into the room with a map marked with blue circles and red triangles. Blue, pumping stations. Red, flak batteries. His pointer tapped the Tegel waterworks in Berlin's north. 8 pumps, 40 million gallons per day capacity, supplies the entire industrial northwest sector, 22 buildings on 11 acres. Then he said the words that made Air Marshal Arthur Harris lean forward. It's above ground, and it's made of brick. The pointer moved. Destroy Tegel, Muggelsee, and Johannisthal simultaneously, and you divide the city's water supply by 3. Berlin doesn't have storage capacity to survive more than 60 hours without these stations operating. Harris listened without interrupting. When Bufton finished, Harris asked one question, and this question tells you everything about how warfare had evolved by 1945. Aiming point visibility, not can we hit it? Not how many bombers? He wanted to know if they could see well enough to put the bombs exactly where they needed to go. Because what the German defenders didn't know, what would make the next 42 minutes fundamentally different from every raid before it, was this. The RAF had stopped bombing randomly. Wait for this comparison because it reveals how drastically the war had changed. 1942, a bomber crew had a 6% chance of hitting within 5 miles of the target. February 1945, Pathfinder Force could place marker flares within 300 yards using radar-aided navigation. Following waves could bomb within 150 yards of those markers. This wasn't area bombing anymore. This was industrial surgery with high explosives. And if you think you know where this story goes, I'm about to show you something that didn't make it into the history books. You're watching history no one teaches. This channel exists because you subscribe. If this is the kind of history you want, clinical, precise, no propaganda, hit subscribe now. Because what happens in the next 8 minutes of this video will change how you think about modern warfare. The bomber stream assembled over Lincolnshire between 2040 and 2115 hours, 160 Lancasters from 1 group and 5 group, 40 miles long, each aircraft separated by 1,000 feet of altitude and 2 miles of distance. But here's what made this different, what made this surgical. Each Lancaster carried a specific load based on its position in the attack sequence. Lead aircraft, target indicators, 4,000-pound canisters that exploded at altitude and cascaded red and green pyrotechnic stars over the aiming point. Follow-up waves, cookies, 4,000-pound cylindrical high-capacity bombs designed to create blast overpressure. Final waves, 1,000-pound medium-capacity bombs with delayed fuses, and those delayed fuses, they weren't for the buildings. They were set to explode after 30 seconds, timed specifically to kill firefighters and repair crews. Remember that detail, because by the end of this story you'll understand exactly how coldly effective that calculation was. The fuel load was calculated to the gallon, and each Lancaster burned 230 gallons per hour at cruise power. Berlin was 580 miles from Lincolnshire. Round trip, 4 hours, 45 minutes. Total fuel required, 1,095 gallons, plus 200-gallon reserve. Total weight at takeoff, 68,000 pounds. That put tyre pressure at 98 pounds per square inch, and required 1,400 yards of runway to unstick. These weren't just bombers. They were flying mathematics problems where every wrong answer meant 7 men dead. And speaking of death, here's where the Germans enter the equation. At 21:47 hours, the bomber stream crossed the English coast at Southwold. Navigation lights went dark, radio silence, absolute. The only communication would be from Pathfinder Forcemaster bombers over the target, directing the attack in real time. Then, at 22:02 hours, German radar detected the formation. The Luftwaffe's 1st Fighter Division scrambled 47 night fighters, Messerschmitt Bf-100s, and Junkers Ju-88s equipped with Liechtenstein SN2 radar. And here's what you need to understand. These weren't the overwhelmed defenders of 1943. These were veteran crews with 600 hours of night operations, flying aircraft that could see bomber exhausts from 6 miles away using infrared detection sets. The RAF bomber crews knew this. They knew the Germans were launching. They knew 47 fighters were climbing to intercept altitude. So how did 160 slow, heavy bombers, flying in a predictable stream, survive what should have been a slaughter? The RAF was jamming. Every 8th Lancaster carried an airborne cigar operator, a German-speaking radio operator who transmitted white noise on Luftwaffe fighter control frequencies. The static was so dense that ground controllers couldn't vector night fighters to intercept coordinates. The fighter crews heard only howling interference and fragments of voices giving contradictory headings. 47 fighters, scrambled, armed, hunting, and completely blind. But 4 Lancasters wouldn't make it home. Remember that number, because how they died tells you just how lethal this airspace was, even with the jamming working. Now, we arrive at the moment everything converges. 22:19 hours. Squadron leader Leslie Hay, flying a Lancaster from 97 Squadron, descended through 18,000 feet. He activated his H2S radar. The scope showed Berlin 47 miles ahead. His navigator, Flying Officer Dennis Matthews, cross-referenced the radar image with a photograph interpretation marked with the Tegel Waterworks location. So he gave Hay a heading correction. 2 degrees left, 2 degrees. At 47 miles, that's the difference between hitting a pumping station and hitting a residential block. In the nose, Pilot Officer Robert Gray lay prone, watching the cloud layer break apart. 24 hours. He saw the city. Not the fires, those would come later. He saw the grid of streets lit by civil defence lamps, the dark rectangle of the Tegel facility, the pale line of the Spree reflecting moonlight. At 22:26:15 hours, Gray pressed the target indicator release. 4 canisters fell away, ignited at 6,000 feet, cascaded red stars over the Tegel waterworks like a chandelier falling in slow motion. Gray's voice crackled over the intercom. Target marked. Red stars. Dead on the aiming point. Haybanked left and climbed, clearing the airspace. His job was done. Now came the mathematics of destruction. The first wave, 36 Lancasters from 83 Squadron, arrived at 22:28 hours. They bombed from 14,000 feet. Each aircraft dropped 1 4,000-pound cookie and 6 1,000-pound bombs. Impact time, 32 seconds. And what happened in those 32 seconds would prove the entire theory of infrastructure warfare. The cookies hit first. Each one created a blast wave travelling 7,000 feet per second, generating overpressure of 120 pounds per square inch within 100 feet of impact. Brick walls designed to withstand 15 pounds per square inch exploded into fragments. Roofs lifted off buildings intact and cartwheeled 200 yards before disintegrating. Then the 1,000-pounders followed, punching through floors already weakened by blast, detonating inside pump rooms and machinery spaces. Yet each explosion consumed oxygen in a 50-foot radius, creating vacuum collapse that pulled walls inward. In 90 seconds, the Tegel waterworks transformed from an industrial facility into a crater field, punctuated by skeletal walls and burning machinery. But here's what the bomber crews couldn't know from 14,000 feet. They weren't just destroying pumps, they were creating a cascade failure. Berlin's water system was interconnected. When Tegel went offline, automatic valves tried to compensate by increasing flow from other stations. When Müggelsee failed 6 minutes later, the load shifted to secondary stations never designed to handle citywide demand. Pipes rated for 60 psi were suddenly carrying 90 psi. At 22:51 hours, here's the moment the system collapsed. A 48-inch main under Alexanderplatz ruptured. Flooded U-Bahn tunnels collapsed a street section 40 yards long. The British had just created a failure mode the German engineers didn't know was possible. The second wave targeted Müggelsee Pumping Station in southeast Berlin. Newer facility, built in 1937, reinforced concrete construction. 38 Lancasters bombed at 22:34 hours. The first cookies blew out the station's steel-framed windows, depressurizing the interior. Then, and this is why the sequencing mattered, follow-up bombs penetrated directly into machinery spaces. A 1,000-pounder struck the main pump hall and detonated between 2 primary pumps, each weighing 14 tons. The explosion severed mounting bolts. Threw both pumps off their foundations. One hit a wall 30 feet away, the other went through the floor. Johannisthal Station, 240 seconds, 41 Lancasters, 164 tons of high explosive, 9 acres. One bomb penetrated 12 feet into the ground before exploding, creating a crater that collapsed the main distribution header. Water pressure dropped from 85 psi to 12 psi in 90 seconds across the entire Eastern District network. The last bomber dropped its load at 23:01 hours. Duration of attack 42 minutes. Total tonnage 2,356 tons of high explosive. And here's the cost. The RAF lost 4 Lancasters. 2 shot down by flak over the target. 85mm guns that fired 40-pound shells to 26,000 feet, creating blast fragments lethal at 200 yards. 1 collided with another Lancaster in clouds over the North Sea, both crews killed. A 4th crashed on landing at Waddington with hydraulic failure, rear gunner killed. Total RAF casualties, 28 aircrew dead. German casualties at the target sites, 347 killed, including 89 firefighters who arrived at Tegel while bombs were still falling. One entire fire company, 36 men, died when a delayed fuse bomb exploded under their equipment as they connected hoses to a hydrant that no longer had water pressure. Remember those delayed fuses I mentioned earlier? They worked exactly as designed. By dawn on February 4th, Berlin's water supply functioned at 22% capacity. Industrial plants in Spandau and Reinickendorf shut down within 8 hours. The Siemens Electrical Works, producing military communications equipment, closed after 14 hours when boilers ran dry. The Daimler-Benz tank engine factory in Marienfelde stopped production on February 6th. Not because the factory was damaged, it wasn't touched. Because there was no water pressure for cooling systems and fire suppression. This is the multiplier effect. This is why infrastructure warfare works. But wait until you see what this did to Germany's overall war production. Albert Speer, Reichsminister for Armaments, wrote in a memo dated February 8th, "The water supply situation in Berlin has reduced war production by approximately 35% across all sectors. Restoration of full capacity will require between 60 and 90 days, assuming materials and labour are available." Then he added one sentence, "Current shortages make this timeline unrealistic." German repair crews worked around the clock. They had pumps, they had pipes. What they didn't have was time. Every repair site required security against air attack. Every crew needed food and shelter in a city where both were scarce. And every repair was provisional, welding patches onto damaged pipes, jerry-rigging electrical feeds, bypassing destroyed sections with temporary surface lines that froze during the February cold. The British knew this would happen. That was the design. An internal Bomber Command assessment dated January 20th, before the operation, stated, "Infrastructure targets offer force multiplication effects. 1 ton of bombs on a power station can halt 10 factories. 1 ton on a water facility can shut down an entire district. The enemy must choose between repairing utilities or repairing factories. Either choice reduces war production." And here's what changed after Operation Thunderclap. February 13th, Bomber Command and the US 8th Air Force attacked Dresden using the same concentrated methods. March 11th, RAF bombers struck the Dortmund-Ems Canal, draining a 40-mile section that supplied water to Ruhr industrial plants. The doctrine that crystallized over Berlin in 42 minutes became the foundation of modern infrastructure warfare. If you believe these men deserve to be remembered, not as propaganda but as they were, subscribe. These stories don't tell themselves, and what I'm about to show you next proves this operation's legacy lasted 80 years. Because here's what they don't teach you in school. This didn't stay in 1945, 1999. NATO aircraft struck Serbian electrical infrastructure using precision-guided munitions, achieving similar systemic effects. 2003. Coalition forces in Iraq targeted water treatment plants and power stations. The doctrine born over Berlin became the playbook. Identify the nodes that enable everything else, and remove them. But before we get to that, you need to hear what the men who flew this mission said about it decades later. Flight Lieutenant Flint's logbook entry for February 3rd reads, "Berlin, waterworks, heavy flak, markers accurate, bombing concentrated, home 235. 21 words summarizing 6 hours of operational flying at 68,000 pounds, gross weight through airspace where 85mm shells created blast zones 400 feet wide. Squadron leader Hay, the Pathfinder pilot who marked the Teagle target, flew 78 operational sorties. He survived the war, returned to his pre-war occupation as a civil engineer, and in a 1983 interview he said, "We didn't think about grand strategy. We thought about wind drift and cloud cover, and whether the navigator's calculations were correct. The strategy was someone else's job. Our job was putting the markers where they belonged." The German civilians who lived through February 1945 in Berlin described the water crisis in letters and diaries. Ursula von Kardorf, a journalist, wrote on February 7th, "The water comes in trickles, brown and foul-smelling. The hospitals are overwhelmed. People are drinking from the canal. The Spree is filthy with sewage. Without water, the city becomes medieval." Medieval. In a city that had been the industrial heart of Europe just 6 months earlier. And here's the mathematics that prove the operation's effectiveness. The US Strategic Bombing Survey, conducted after the war, calculated that Operation Thunderclap reduced Berlin's war production by 28% for 40 days. The survey noted, this operation achieved greater economic effect per ton of bombs than any comparable area attack. The concentration of force against a small number of critical nodes produced systemic failure across a broad industrial base. Let's do the cost-benefit. Operation cost, £7.2 million and 28 aircrew lives. Production loss to Germany, 12,000 tons of munitions, 2,400 tons of optical equipment, 8,600 tons of electrical components, replacement cost at 1945 values, £84 million. For every pound spent, Germany lost 11. For every life lost, hundreds of tons of war material never reached the front. This is why the mathematics of infrastructure warfare are so brutal. Berlin's water system never fully recovered before the war ended. By April 1945, when Soviet forces entered the city, water pressure citywide was 40% of pre-war levels. The final RAF raid on Berlin occurred on April 20th, Hitler's 56th birthday. It targeted rail yards. But water pressure was so low that firefighters couldn't suppress blazes started by incendiary bombs. Fires burned for 3 days across districts that hadn't seen significant bomb damage in months. One operation in February created vulnerabilities that compounded for 3 months. That's the cascade effect. The men who planned Operation Thunderclap understood something that aerial warfare had been learning since 1939. Destruction is easy, disruption is decisive. You don't need to obliterate every factory if you can remove the water that cools the machinery. You don't need to kill every worker if you can eliminate the infrastructure that allows them to work. The Lancaster bombers that flew to Berlin on February 3rd were metal tubes carrying young men and high explosives across 580 miles of hostile airspace. The oldest crew member in the operation was 29. The youngest was 19. They flew at night through flak that could shred an aircraft at 1,000 yards, guided by radar sets that sometimes lied and target markers that sometimes missed. They did it because the mathematics said it would work, and it did. By the time the war ended 92 days later, Berlin's water supply, 61% capacity, Tegel Waterworks, inoperable, Muggelsee Station, 3 pumps functioning out of 8, Johannisthal, running at 40% capacity with provisional repairs. The city's fire brigades had given up trying to maintain pressure standards and simply connected hoses to whatever main still functioned. The strategic lesson outlived the war. The bombing didn't end World War II. Soviet artillery did that. But the bombing changed how wars are fought, not by destroying armies, but by dismantling the systems that sustain them. On February 3rd, 1945, 160 bombers proved you could collapse a city without burning it to the ground. You just had to find the pipes. If this stayed with you, press like. In one word, tell us in the comments what this was. Raw subscribe. Because when history stops being examined, it turns into myth.